Hi everyone, today we're going to cover theoretical and experimental probability to build upon our lesson from theoretical probability last week. So to get us started, we're going to visualize this using an exemplar. So the exemplar I've picked for today is a dice game. So essentially, I had a pair of colored dice, and we have the following game board. It's like a grid pattern. So every time you roll, one on the gold, one on the blue, or vice versa, you put a tally in this square. If a combination's already been rolled, you add another tally to it. The idea is that you roll as many times as you need to fill up this entire board. And some of them obviously you'll roll more frequently, some of them less frequently, but again, there's no set number of rolls. When we're doing the experimental today, it's just as many times as it took me to fill up the board. So we're going to determine the theoretical of rolling a 2 and a 3, and also determine the experimental. So one thing to know before we get into this, a 2 and a 3 could be a combination of 2 on the gold, 3 on the blue, or 2 on the blue and 3 on the gold. That's very important. If I'd said what's the probability of rolling a 2 gold and a 3 blue, then obviously there's only one option there. But we actually have, in fact, 2, when I'll demonstrate that on the next page. So when we're calculating theoretical probability, we covered this last week, it's the number of favorable outcomes, the number of outcomes that you want, versus the number of possible outcomes. So this gets a little tricky in the sense that this game board, it kind of complicates things beyond some of the homework that we did last week. So theoretical probability can be summed up, once again, as FO over PO, favorable outcomes over possible outcomes. So for possible outcomes, if we were, for every gold one, there's 6 possible outcomes. If you were to make a tree diagram, like we did on last week's video with the flipping of the coins, that would be 6 possibilities for each gold. Now we have to keep in mind that there's also the possibility that there's 6 unique outcomes if we start with blue, right? A 1 blue to 1 gold is different than a 1 gold to 1 blue. If you can imagine it like rolling them in a left and right bin or something like that. In theory, or at least in this example, we're going to count those as different outcomes. Rolling a blue first and a gold second versus a gold first and a blue second. So that means there's 36 possibilities starting on gold and 36 possibilities starting on blue. That's a total of 72. So there are 2 favorable outcomes because 2 and 3 gold is a different outcome than 2 gold and 3 blue. Once again, we're going on the 6 by 6 for each of these, as you can see to the right. So that gives us 72 possibilities. That's 2 over 72. 2 possibilities that we want, favorable outcomes, and 2 that, or 72 that are potential outcomes. I'm going to reduce that by dividing both the numerator and the denominator by 2, lowest forms. That gives us a theoretical probability of 1/36. Or 1 in 36. So for the sake of time, this took me about 40 plus minutes to roll 2 colored dice, 1 gold, 1 blue. So I just put together my tally. You could do this at home if you really feel like that would benefit you to practice it or to see it for yourself. But this is what my page looks like. Just to remind you, I'm using regular tallies up until 5. I just put a V for 5. I know that's a little strange since 4 is a IV in Roman numerals, but that's just how I did it. I guess that was easy for me at the time. So just to clarify, the V's are 5. So if we want to determine experimental probability, so this is the experiment that, the probability that you create by holding an experiment, and it'll be different for everybody. That would equal the number of favorable occurrences. So occurrences are things that happened. So it's not necessarily the things you want to happen, they're things that actually happen during your experiment, over the total number of occurrences. So again, if it took you 25 times to roll this, then it would be over 25. If it took you 541, it would be over 541. We actually have to add up all of these tallies to figure out what the total number of occurrences is. So again, we can summarize this by saying EP, experimental probability, is favorable occurrences over total number of occurrences. Now in this case, to go 3 to 2, there were 3 occurrences. To go 3 blue to 2 gold, there were 5. So if we add those up, that's 3 plus 5, and if you count all these together, there were actually 90 rolls. So our number of favorable occurrences was 8. So a combo with a 2 and a 3 happened 8 times out of 90 rolls. I divided that by 2 to be 4 over 45, so it's 4/45ths chance that you will roll, or that I did roll, a 2 or 3. So let's compare this now with our theoretical to our experimental. So experimental was 4/45, and theoretical was 136. So in practice, I rolled a 2 and 3 with a 9% probability, right? To put into percentages, because for some of us that's easier to see, especially when the fractions don't have common denominators. And then theoretical actually said I would only roll it 3% probability.